Hi, continuing our study of integration by parts, the definite integral, and other cool tools for this. So you look at this graph and you say, wow, what is this? And well, this is Mrs. Allen, and we're in calculus, BC, and we're studying integration by parts. This is an odd function, right? You can see that the symmetry is origin symmetry. We could find the area under the curve if we pop this into our calculator, but now we're going to deal with looking at a method to be able to integrate this product function, x squared times sine x. So a little different from our first example, but we're going to go right on to our first example that I've already started to set up from yesterday's lesson. So what I've done is I've said I need to pick a u that's differentiable and a dv that is integrable. Let me highlight these here. So I picked a u that was x squared, clearly differentiable, and then a dv that is integrable. So now there is a little pattern we'll talk about in just a minute, but so I set forth and I say, and if you're doing this and you say, here's my u, here's my dv, and it gets more complicated, then what you want to understand that you probably have the wrong u and you want to switch them. You probably have the wrong u and dv. So with this, you can see I pick the u, and then I have the du and the v from the dv, and set everything up in the first step go around. So now what I would do as a student, I would want to simplify this. I'm going to stretch this out just a little bit. So I would want to make sure before I went on to the next step that I've got this simplified enough so it's clear to me what I have, because it is confusing sometimes with everything else that's floating around. I want to simplify where I can. So I'm going to simplify with the 2 and the 1/4, and then I get this is plus 1. It's going to be 1/2, and then I have the integral of x times cosine 4x. And again, it's just going to simplify this a little bit. Okay, so there you have it. Okay, now I can integrate a little bit easier going through this next step, because I'm going to have to use this integration by parts one more time. So a repeated method. So that's really what I'm doing this first part. In problems that require repeated applications of the integration by parts method, a tabular method can help to organize it. But we're going to go through it first so you can see what I mean by making it easier, or it organizes it. So here we go. So we're going to keep the first term, that first uv, the same. Just remember to carry that with me. Now I'm going to leave the 1/2 out front, and then you can see that with this integral that you have here, that's another integration by parts. So what I'm going to do is go back and I'm going to say then I'm going to pick another u. So my u is equal to x, and therefore my du is equal to dx. I like to draw a little line here. Maybe I'll even draw a double line. And then I have my dv is then equal to cosine 4x dx. And my v then will be equal to, now remember you're taking the antiderivative, so it's going to be 1/4 sine 4x. So you got a short little u sub in there with the 4x, all right? So now I'm going to fill this in. So I have 1/2 times uv. Now I have a new uv. Here's my uv. So it'll be x over 4 sine 4x minus the integral of v du. So that would be then 1/4 sine 4x dx. So du is equal to dx. And there you have it. So now all I have to do is integrate this last antiderivative. So I have negative x squared over 4 cosine 4x, as you see, cosine 4x, and then this is going to be plus x over 8 sine 4x. And then I'm going to distribute, I'm going to have a minus 1/8, and then the antiderivative of sine 4x dx. Okay, So now I have one more step to take. I'm just make it a little bit larger so I can fit it in there comfortably. And let me move this stuff just a little bit. Okay, so now I've got, this is equal to, maybe a little bit bigger. So negative x squared over 4, coming close to getting done with this, and plus x over 8 sine 4x minus, now I'm going to take 2 steps. I'm going to do an erasing since I'm at the end of my job here. So now this is 1/4. Now I want you to think for a second. Using it, sine 4x is the derivative of what? Negative cosine. So there's going to be a negative here, which is going to make a negative times a negative, which is a positive. And this is going to be 1/32. So it's going to be plus 1/32. And I'm just going to erase this. So it'll be plus 1/32 times cosine 4x. Oops, I need to get that with it. Cosine 4x plus c. There you have it. There it is. There you go. There's our answer to the first example. What is the antiderivative of x squared sine 4x dx? Okay, so now what this guy, Jaime Escalante, said, there is an easier way to do this, and he discovered a pattern with it. Jaime Escalante, made famous by the movie Stand and Deliver. So one comment I want to make about this, on the last example, we picked our U's because our U's were algebraic and then our DV's were trig. So you go with this hierarchy of choosing your U, starting with logarithms on down to exponential functions. So if you look at this one, we have our U is x squared because it's algebraic. And the trig function is the dv then. So I'm only going to put sine 4x here and leave the dx off. We're going to keep taking the derivatives here. So this is the same problem, if you notice. Same problem as the last example. So I'm showing you Jaime Escalante's method. He would do a table, and this would often keep students organized. So our U, notice I have plus or minus, and that's because of the plus UV minus the integral and the alternating nature of that. So we have x squared, 2x, 2, and 0. Sine 4x, we have negative 1/4 cosine 4x. Then we have negative 1/16 sine 4x. And then we end up with 1/64 cosine 4x. Okay, so that gives us our table of values. We've taken the antiderivatives. Now what we're going to do is we're going to do a tic-tac-toe-ish kind of thing. We're going to say plus. Actually went in a different color, so let me go highlighter. So here we go there. We go here. We go here, right? So stick with me on this. So what we're going to do is we're going to multiply these. So go back to your antiderivative here. So that is then equal to plus x squared times 1/4 cosine 4x. That's easier if we just write it like this. Minus x squared over 4 cosine 4x, and then plus, because we have minus a minus, so it's going to be plus 1/8. So it's going to be x over 8 sine 4x. Kind of looks familiar for the last example. It is the same thing. And then the last one we have is plus 1/32 because we have 2 times 64. 2 times 1/64. And then we have a cosine 4x. And then we have the arbitrary constant plus c. And you can see that that gives you the exact answer that we have above. Okay, so just a quicker way of handling this integration by parts. So here's the Lie8. So again, just mentioning that as my mnemonic, the mnemonic device to be able to choose your U. So we're going to use this tabular method for this problem. So now you have your U checked out, that you have U is equal to x squared minus 1. So you have our first derivative of that is 2x, 2, and it's the same as the last one, different expression, the same. And then to take the antiderivative of e to the x, that's just e to the x all the way down. So we could quickly say, we look at this one and we say, okay, we want to find the integral from 0 to 1. This is a definite integral. So with this one, we're going to have to remember to evaluate in the end. So the way we're going to handle this is we're going to say, all right, here's the U, the first UV, second UV, and we use a pink for this. Here's our first one, here's our second, and here's our third product. And we're able to just answer the question very quickly. Here for the antiderivative, we get x squared minus 1 times e to the x. And then we have minus 2x e to the x, and then plus 2 e to the x. Now, we're going to evaluate this from x is equal to 0 to 1. But I look at this and I kind of want to simplify things a little bit here before I answer it. So I'm going to say it's x. I'm going to factor out the e to the x. So remember, you can factor to simplify. So here we have from x is equal to 0 to 1. So that would simply be, if I look at this, this is going to be x squared minus 2x plus 1, which factors as x minus 1 squared e to the x. And then we would evaluate from x is equal to 0 to 1. So as I said, we have an equivalent expression here, and so it became this quantity squared. So now we're going to evaluate that from x is equal to 0 to 1. So we get, and it's kind of easy to see this, but I'll plug in. So I get 0 squared times e to the first minus negative 1 squared times e to the 0. So clearly you can see that your answer is then negative 1, 0 minus 1. So your answer is negative 1. So the integral of x squared minus 1 e to the x dx from 0 to 1 has a value of negative 1. And one of the things that I often did is I kept a graphing calculator handy, and I would often just check my answers as I derived them on a calculator. Okay, let me see if I could draw this rectangle around. Doesn't want to draw it, but there's the answer. I'll leave it in there. Okay, here's another problem that I want to handle. It's slightly different. And this next one, you've got, and if you want to pause your video, by the way, if you feel that this is going too fast, just pause your video and go back and see if you can review the parts that maybe you had difficulty with. Okay, so this last one is dealing with non-terminating factors. So for this one, I'm gonna feel like I'm caught, like I'm feeling like it's cyclic, somewhat cyclic. Oh my gosh, I have the integral that I'm trying to solve for in the actual equation on both sides. So let's see what we get here. So I start the first go around with this, and I get that the integral is equal to that expression that you see. So with this one, I'm gonna take the time, and because I know that the sine and the cosine are gonna do some flipping here, I'm gonna be careful on the left-hand side. I'm gonna keep writing what I'm looking for. So now we're gonna do a little u substitution here with this last integral. I'm gonna put the work up here. I'm gonna change colors here just to differentiate between the one. So I'm gonna say my u, remember you have this Lie8. So again, Lie8. So you have an exponential function and a trig function. So the exponential function is not gonna be the u, the trig is. So we have that u is equal to the cosine, just the same way as the sine was. And then du is equal to negative sine x dx. And then you have your dv is equal to e to the x dx. And then your v is just e to the x. So as we complete this last integral, then we end up with another uv. So it's going to be e to the x. Let me go back to purple here. So it'll be e to the x times cosine x minus the integral of v du. So then that's going to be minus sine x. Now let me put the v first here with this. So it'll be v e to the x times minus sine x dx. Okay, now you've got a few minus signs working around here. So I've got the integral of e to the x, and at this point I recognize that I have e to the x sine x on both sides. So I have e to the x, and one of the things I was always careful with was the idea of having negatives or subtraction signs. So we have e to the x cosine x, and then this becomes plus the integral of e to the x sine x dx. And then we have a minus sign out front. And though I am taking the time in this video to show you the steps, I know that there are times where I often just do slash marks through the minus sign and make it positive. But I just want to make sure that I don't lose anyone here. We have e to the x cosine x, and then this becomes minus, then minus the integral of e to the x sine x dx. So now at this point, we want to take and add our e to the x sine x integral to both sides, because we notice we have it on both sides. We could say I'm going to add the same thing, e to the x sine x dx to both sides. And then we end up with two integrals of e to the x sine x dx. Boop, just going to back a little bit here. Sine x dx. And that's equal to e to the x sine x minus e to the x cosine x. Okay, now you're thinking, all right, I just divide by 2, right? So we'll divide by 2 and we get the integral of e to the x sine x dx is equal to 1/2 e to the x. So we write e to the x over 2. Doesn't really matter. E to the x sine x minus, so I'm just going to divide everything by 2. So each term gets divided by 2, e to the x cosine x. And at this point you realize that this is an indefinite integral. So you need to put in the arbitrary constant. So we'll just write plus c and we have our answer. So this is when you will see you have a repeated instance of the integral that you're trying to solve for. And when you do that, you're looking for non-terminating terms. It's like, oh my gosh, non-terminating integrals, we have it on both sides of the equation. And that occurs for this one right here and here. And that's a sure sign that the strategy that you're going to use is add the integral to both sides and solve for the integral. So that's all I have for you today for integration by parts. And we'll come together in class and we have a few activities. We're going to work on practicing selecting U's and DB's before we begin. Probably practice some old integration techniques using U substitution and other trig and inverse functions. But that's it for today. So have a great day and we'll see you later. And we'll see you later.